Hello, my dear students. Let's start our practice 3. Our course is Neural Networks, and let's consider exercises for practical work 3. Find the result, the output of a given neural network, figure 1, using a sigmoid activation function. Let's consider our small neural network. It consists of 3 neurons. Neuron 1, H1, neuron 2, H2, and neuron 3, H3. Here we have 2 inputs, input 1, X1, and input 2, X2. And we have here 2 layers. Layer 1, it consists of 2 neurons, and layer 2, it consists of 1 neuron. Sometimes they say that this is our inputs, it's like an input layer, but it's not a layer, it's just inputs. Okay, we count like this. Layer 1 with 2 neurons and layer 2 with 1 neuron. Okay, here we have connection. This connection has weight 1 and W1, W2, W3 and W4, W5 and W6. How to find out output of this neural network? Why? First of all, we need to find output of neuron 1, then to find output of neuron 2. These 2 outputs of these 2 neurons will be input to neuron 3. And how to work here, how to calculate output of 1 neuron with 2 inputs. We know we did it in our practice 1 and practice 2. So let's calculate outputs of all these 3 neurons, and the output of our neuron number 3 will be the output of our neural network. And please note that we divided our task into 3 small tasks that are like our task in practice 1. So this our practice 1, this our practice 1, and this our practice 1. And here we have values for input 1, for input 2, and weights. And please note that here we have negative values, like here and here. I always told that we take our weights from the range from 0 to 1, but it's just a task to train, and we may use these negative values, and sometimes, yes, we use negative weights for our neural network, like here. And please note, here we have this number and this that are more than 1. So we just calculate it, just see on our output. And I remind you that first of all, for each neuron, we find out some function using this formula. Please look practice 1. And then we apply activation function, sigmoid activation function, to our value, to our sum function. And please note, alpha is equal to 1 in this formula. And okay, when we find out this output, you may do the second part of our practice. Okay, we'll do it and we'll check it later. But the second part of our practice is do the same. Find out the output y, but now please add biases to each neuron. This is our additional input bias that is always equal to 1, but it has a weight W0, some value from range from 0 to 1, but it may be negative, of course. And it goes to neuron 1, to neuron 2, and to neuron 3. So this is the second part of our program. And now let's consider our first part, how to find out output of neuron 1. Okay, first we calculate our sum function for neuron 1. It will be x1 multiplied by w1 plus x2 multiplied by w3 here. And then to this value we apply sigmoid activation function. Let's see this. So 1 it's our input 1. This value it's our w1 input. 0 this is the second input multiplied by weight w3. So we'll have this for our sum function. Let's check this value and this value. Let's check w1 and w3. Yes. So we find out some function and then we apply sigmoid function here to this number, and we'll take this number. We'll check it later using our program. Okay, I write like this, the same with our notation. Sum function for neuron 1 and output y1, output of neuron 1. And for neuron 2, for this neuron, how we find out our sum function? We multiply x1 by w1 by w2 plus x2 we multiply by w4. So now we know our sum function. Let's check. This is our sum. Sometimes we call it input to neuron. So it's input to neuron H2. And we multiply our first input multiplied by W2 plus second input that is equal to 0 multiplied by W4. Let's check. Please remember these values. And let's check. W4, yes. W2, yes. And W4, yes, the same values. So we have calculated right. And now we apply to our sum function our sigmoid function. Here, please note. And this it will be output of our neuron H2. And I rewrite the same. Input to our neuron H2, it's our sum function here, and output of neuron 2, this is our Y2, because Y it's equal, we write like output of the neuron, and then our two outputs this output and this output will be input for our third neuron. So now we do the same. We find out sum function for neuron 3 and then we apply to this value our sigmoid function, like here. We find out some function for neuron 3, and then we calculate output of the neuron 3, and it will be output of our neuron network. Okay, and let's consider our program. I put here, to save our time, program, and we'll I'll explain it. Okay, let's start. This is our activation function, sigmoid activation function. Then we start our main program. You may see how I explain it in our practice 1. And here I declare x1, x2. This is our inputs. And this is our weights. W1, W2, W3, W4, W5, W6. Our weights. Then I call them Z, but it's our S. As some function of neuron 1, some function of neuron 2, and some function of output neuron, of neuron 3. And they are outputs. Output of neuron 1, output of neuron 2, and output of neuron 3, that is output of the whole neuron network. And here text for user, enter x1, and I put from keyboard my x1, then enter x2, and I put my x2, then enter w1, I enter my w, my way, the first way, and so on, all the weights. And then let's consider here I calculate some function for neuron 1, and then in this I call activation function, so I calculate output of neuron 1, here h1. Then I display on the screen h1 is equal, and here goes value. Then I calculate some, here in this line, some function for neuron 2, and then I call activation function, so I apply activation sigmoid function here. For alpha in our formula is equal to 1, please note. And then I display on the screen h2, output of my neuron 2, is equal, and here goes value. Then I calculate in this line some function for my neuron 3. Then I call activation function, sigmoid activation function, and on the display output of all neural network is equal, and here goes value. Let's check. Let's check with the values in our doc document. I have them on my photo. Now I'll open my photo and just input them. Okay, I run my program. Enter x1 was 1, then x2 was 0, w1, the first wave was 0.45, the second weight was 0.78, then the next weight minus 0.12, the next weight 0.13. Let's see. Okay. The next 1 and 0.5, and the last with minus 1.3. Okay, enter. And here we see the answer. Output of neuron 1 is equal to 0.61. Please remember. Output of second neuron is equal to 0.68 and round to 69 because here goes 5. And output of all neuron network and output of the neuron 3 is 0.34. Let's check. Please remember these values and let's check. This is our task, our calculation. Yes, this value output of the neuron 1 is equal this. Output of neuron 2 is equal to this. And output of neuron 3 and of all our neuron network is equal to this. That's right. Our program is very good. And now let's add biases to our program. I'll copy them here to save our time and put in my program. Okay, it's text for user. Please enter biases. Okay, and now I need to declare my bias. So I declare bias. This is the name of my bias. Oh, okay, like here. So I declare. Now I enter it, and then remember that bias is just additional weight to our neuron. And let's check our picture, our figure. Let's look at it. Okay, here we have additional weight to each neuron. To neuron number 1, additional weight to neuron number 2, and additional weight to neuron number 3. So let's add this additional weight to each sum in our program. Okay, here we print in from the keyboard value for bias, and now we add it to sum 1, to sum 2, and to sum 3. Here goes our sum 1. So let's add it. Okay, and then we add here like this, and to third. Okay, and please remember these values. Please remember our output. And now we put our bias. Not now, but now we'll do it. Okay, the same value just to compare. I want to print the same values. Okay, x1 was 1, x2 was 0, and our weights. The same value as the first time, 3 with minus. And then 1.5. Please look at it. And the last with minus. And now our bias. Oh, I don't know why. I don't know why. I think something maybe something with internet, but I declare my bias. Let's run again, but with any numbers, just to save time. Oh, yes, enter wait for bias. Now it's working, so it's what's the problem with internet. Yes, okay, please note, it's not the same values, but our bias shifts the answer to 1 because it's positive, so it shifts. Let's check, let's try. I hope that with internet everything will be okay now. We just check. I want to check it. So this value, then 0, then minus, let's shift, enter, and for 0, 13, then 1.5, let's see, then minus, yes, and it will be like this, and now it's shifts. Yes, please note, it was 0.34 and now it's 0.44. So our biases always shift the decisions, shift our output. And this is the end of practice 3. Thank you very much. See you.